We have one problem here that says, is 53,240 a perfect cube? If not, then by which smallest natural number should 53,240 be divided so that the quotient is a perfect cube? So this word is important, the quotient, and here you have to divide, you don't have to multiply. Since you are dividing, therefore this word quotient is appearing. Now 53,240. First, let's check it whether it is a perfect number or not using prime factorization method. So if you divide this by 2, then 2 to 4, 2 6 12, 2 6 12, 2 to 4 2 0, then 2 1 2, 2 3 6, 2 3 6, 2 1 2 2 0, 2 6 12, 2 6 12, 2 5 10, 2 5 10, then 5. So 5 1 5, 5 3 15, 5 3 15, 5 1 5. Now this is 11. So 11 times 1 is 11, and 2 22 1, and then you have this one. So if you express 53,240 in terms of its prime factors, then it becomes 2 multiplied by 2 multiplied by 2 multiplied by 5 multiplied by 11 multiplied by 11 multiplied by 11. Here we have three prime factors, 2, 5 and 11, of which 2 appears 3 times, 11 also appears 3 times, but 5 only appears one time. Clearly 53,240 is not a perfect cube. Now we have to make it a perfect cube, not by multiplying by a smallest natural number, but by dividing. Okay, so if we get rid of this number 5 by dividing it by 5, okay, by dividing it by 5, so you'll get rid of this 5. So finally your number becomes 2 multiplied by 2 multiplied by 2 multiplied by 11 multiplied by 11 multiplied by 11. Okay, now this is a perfect cube. But wait, what we have actually done? We have actually divided this number by 5. This is expression of, we have expressed 53,240 in terms of its prime factors. Okay, but when you divide this by 5, it means that you are actually dividing this number by 5. So if you, the answer that you get here after dividing it is actually the quotient of this division. So divide it like this, 53,240. Now whatever quotient you get from here, you can also get from here as well by multiplying this one. Okay, so 515, this gives you 1, sorry, gives you 0, then you have 3, so it goes 0 times, then 2, so 5 6 30, you get here 2 is 4, so 5 4 20, you get 4058. Okay, so your number is 10,648. 10,648. So 5 is that smallest natural number which when divides this 53,240, you get a perfect cube, and that perfect cube, that is the quotient, is 10,648. that is a perfect cube. Same problem, but we have a different number here. Here you have 11,888. First let's check whether this number is a perfect cube or not using prime factorization method. So it is 1188, and if you divide this by 2, you get 2 5 10 2 9 18 2 4 8. Here you have 2 2 4 8 2 9 18 2 7 14. Then you have 3 So 3927 and again 3927, you have 33, you have 11, you have 1. So if you express 1188 in terms of its prime factors, it becomes 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 11. Okay, so we have 3 prime factors, 2, 3 and 11, but only 3 appears 3 times, 2 appears 2 times and 11 appears only 1 time. So 2 is not appearing 3 times, 11 is also not appearing 3 times. It means that this is not a perfect cube. So we have to divide so that the quotient becomes a perfect cube. So what we can do first, divide this number by 2 multiplied by 2, that is by 4, then multiplied by 11. That is, if you divide this whole by, this is actually what? This is 44. And we can write 44 as what? 2 times 2 times 11. 2 times 2 is 4 times 11 is 44. It's actually 44, right? So what we have done actually, we have actually divided this number by 44, right? So this 2 gone, this 2 and this 2 gone. Here this gets cancelled. Okay, so you are left with only 3 times and 3. Okay, so what's the quotient that you get here divided? You can simply tell the answer as 27. You'll get 27. But if you want to check, you can check here. Divide this number by 1188 by 44. So you get 2, you get 88 here, and here you get 0, then you get 3. So this, you get 8 here, 7 times, you get 308, right? So your answer is 27. So 27 is the quotient now that is a perfect cube now. And what is that, which is that smallest number that you have used to divide this 1188 by? That number is 44. So this is the smallest natural number.